Welcome to ScalaUA conference.
Okay, hello everyone. Let's just wait for them to get those chairs out to the apparently more popular other talk. Let's just wait a few seconds. Let's start shortly. Oh, yeah, sure, just a minute. Huh? Oh, just, yeah, okay. Okay. Okay, I think we're about ready now. So, my name is Luka Jacobowitz. I'm from Germany. I work at a relatively large consulting firm, and I have the privilege to write Scala as a living. And today I'm going to be talking about reactive programming in the browser, especially with Scala.js and Reactive X, which we'll look at in more detail very shortly. Basically, the contents of this presentation, they're not completely specific to Scala.js, but can be applied to other functional languages. They could theoretically even be applied to non-functional languages, but why would you do that? But yeah, I'm going to, obviously, because this is a Scala conference, I'm going to be focusing on Scala.js. So, how many of you have heard of Scala.js before? Okay, how many of you have used Scala.js? That's still quite a lot, that's pretty cool. Okay, so for those that don't have a clue what it is, it's basically a Scala to JavaScript compiler. So it takes Scala source code, and instead of compiling it to JVM bytecode, it will compile it to JavaScript. And so let's talk a bit about the motivation. Why would you want to use Scala.js? And first things first, the modern front-end architecture always includes some kind of build step, right? So I think no one here actually still writes JavaScript or ECMAScript 5. I think most people probably use ECMAScript 6, they use TypeScript, they use Flow. They always have some kind of compile step, right? So even if you don't have this compile step, at the least you'll probably do is you'll be minifying. So you always have this source code transformation step. So the argument that it's some kind of overhead, I think today it just really doesn't apply anymore. And the second argument that I think is a lot cooler, obviously, is because that you can easily share server and browser code. What that means, basically, is that if you have some kind of model or some kind of validation, that usually when you have two different languages, you have to write them twice, right? So you implement some kind of complex validation for, I don't know, some complex form, and then you have it on your server, and then you just have to re-implement it on the browser, or the other way around. It's just, it's annoying, personally, and yeah, if you can just use the exact same code, you don't even have to copy paste it, you can just import it from a shared folder, right? And the other thing is that obviously you just get rid of any synchronization issues, right? If you have some kind of model and then you add a field, usually what you have to do is you have to add it in your 3 layers, right? You have the database layer, where you have to add that field, and then you have to also add it on the front end. So with the database layer, you could use some kind of database migration tool, like some ORM or anything like that, and you can basically mitigate that, but in the front end, usually you can't really do that unless you use the exact same language. So that's another great positive. And the third aspect I want to talk about is you can leverage existing Scala libraries. I'm sure most of you know Shapeless, Cats, ScalaCheck, ScalaZ, Scala Test, all of those super cool libraries that we depend on in our day-to-day programming. We can just use them without any extra step in the browser. Like, I think the only extra step is in your build SBT, you have to add a single % sign. I think that's not really much of a hassle for most people. And the fourth thing I'd like to talk about is the interoperable, that is such a difficult word, interoperability with JavaScript. Which means that basically when you use some kind of compile to JS languages, usually the hardest part is interfacing with some existing JavaScript library, for example, some, I don't know, like Bootstrap, material design libraries. There's a lot of libraries that usually you want to use, like some date picker, color pickers. Usually you want to have to use them, and in my own experience, some languages kind of make that difficult. If you just think about Elm or ClojureScript, JS interop is really not that easy. And with Scala.js, they made it an imperative to make it as easy as possible to interoperate with JavaScript. So you can use dynamic types in Scala.js if you want to forgo type safety, or you can just create a trait and then you get all the type safety. So let's go into Scala.js in a little bit more detail. The first thing is there's of course some limitations. We can't compile any arbitrary Scala code, and of course every Scala code that has threads or parallel code, it cannot work natively in JavaScript, because JavaScript is inherently a single-threaded environment. The same goes for reflection, because reflection, if they added reflection to the compiler, it would introduce a huge amount of overhead. And typically, like the Scala community, at least as far as I can see it, they're all moving in a direction towards compile time safety, compile time reflection with macros, or something like shapeless. So the usage for runtime reflection, really, I don't think it's the future of Scala, to say the least. So it's not really relevant because, yeah, exactly. And the second part that's really cool to me is Scala.js natively does dead code elimination. So what that means is if you have like, if you import some kind of library like Cats or any other big library like Shapeless, and you only use like a couple of methods, then Scala.js, the Scala.js compiler, will just completely get rid of all the rest. And that means like the bundled JavaScript will be smallish. It won't be small because it still has to implement the whole Scala runtime, but it will be smallish, to say the least. So, and the third thing is source maps. Who doesn't know what source maps are? Okay, there's a few. Okay, source maps basically map a source code to underlying JavaScript code. They're heavily used in compile to JS languages, and that means basically when you get an error in your JavaScript, in your resulting JavaScript, and you don't know what it means, then you can just open the console in the browser, and then you can see the Scala code, so you don't have to see the awfully ugly JavaScript code that the Scala.js emitted. Okay, that's it so far. The next question user interfaces, which are inherently, like most of us think of programming user interfaces in a very imperative way. So how can we do that with Scala? How can we leverage Scala's functional programming capabilities? And to answer that, we're going to have to look at, actually there's several ideas, but today we're going to look at something called functional reactive programming, which was coined by Colonel Elliott in 1997, so it's kind of oldish, like almost everything in computer science. What basically his idea was is that a lot of the time we abstract over a lot of different things, like for example, the garbage collector lets us abstract over memory cells, and his idea was to abstract away time, so that what we have essentially is an abstraction over time, and I'm going to show you in a second what that means. And basically, reactive programming at its core is just programming with asynchronous data streams. And a stream, unlike the native Scala collection stream, is something like a value over time. For example, if I have a mouse position and I move it, then the value will change over time, and a stream is just a representation of that change. I'm going to show you a simple example right here. This is basically like a time diagraph, right? So this is someone, some guy, he's just writing in hello on his keyboard, and for some reason it's all caps. Probably some idiot had caps lock on or something. And I don't know why it takes so long for that second L, but basically these are values over time, right? So if you look at the start, the H all the way over the left, that's maybe like 3 p.m. and then at the end it's like 3 p.m. and I don't know, 10 seconds, how long? Probably shorter, 5 seconds. Let's say it takes 5 seconds to write that word. So these are values over time. And the cool thing that we can do with functional programming, reactive programming, is we can abstract over this. That means we can use all the functional methods we know, like map and filter, or similar things. We can use them to manipulate these data streams. And that's how this looks. Basically, we call a map method with just a single function that says just transform everything to the lowercase. And what we get, like when we call map on a list, we get a new list, right? So if we call map on a stream, we get a new stream. I think it's pretty simple actually. So now we have these two streams that emit these two very different things at the same time, basically. So I don't know about you, but this doesn't really represent anything like UI programming, because what's missing is the ability to reason about state. Right? State is probably the most difficult thing in UI programming. And the most important thing in reactive programming, at least the way we do it with ReactiveX, is the scan function. Does anyone know what the scan function does on a list or a vector? Okay, that's not many, because it's not really all that useful on a list or a vector. But basically, what it does, it's like a fold or a reduce. It traverses the whole data structure, but instead of returning one element at the end, it will return intermediate values every time. So if we have a list of 1, 2, 3, and we call fold with plus, we get 1 plus 2 plus 3, so that's 6. But if we call scan with plus, we get a list of 1, and then 1 plus 2 is 3, and then 3 plus 3 is 6, so we get a list of 1, 3, 6. And the same works on streams. So this is just basically the same with string addition, string concatenation. So what we get here is a stream that at the end will emit a hello, right? So this is the very, very basic idea of handling state in in reactive programming. Okay, so far so good. So how would we go and implement this with Scala.js? And the answer is Arc Scala.js, which is just a port of Arc Scala. I'm sure some of you have heard about it. And Arc Scala is inherently a wrapper around Java but also made Scala idiomatic. And Arc Scala.js is basically the same, but instead of wrapping Arc's Java, we just wrap Arc's JS. And observables that we find there are just those plain streams of data. And the really, really cool thing about this library is that it does exactly what Conal Elliott was talking about. That allows you to abstract over time, which means that in addition to these methods with like map, filter, and scan, we get methods like debounce time, which means that basically if you think about like an autocomplete text field where you want to do an HTTP request, like a search basically, and what you can do is like from the browser, from the text field, you can just send the text input, the query, to the server on every keystroke, but that's completely unperformant, right? You don't want to send 50 HTTP requests to the server. So what you do is usually you wait a certain time until the user has completed its input. But to do that, it's extremely difficult if you don't have these kind of abstractions, right? You have to wait, and then you have to see, oh, did the user input something? And it gets messy really fast. But in Arc Scala, there's just an operator for that, and that's basically the gist of the library. There's an operator for almost anything you can think of. You can call the debounce operator, and then it will just wait 300 milliseconds for another input, and otherwise, and then it only if you didn't put a keystroke after 300 milliseconds or whatever time you choose, only then will it actually send an HTTP request. And it's a single line of code, and it's extremely concise. Okay, so we're gonna check out some code right now, and wish me luck for the live coding. Okay, so what we're going to do is we just want to make a simple app that has a button, and we just want to see how often that button was clicked. So it's the very most basic thing you can think of, but it does hold state. So what we're going to do is we're just going to grab the containing element in the DOM. We're just going to say document.querySelector. And then what we're going to do is we're going to create a button. Create element button. And we're also going to give that button some text content. Text content. We're just going to say click me. And then we're also going to create a resulting element, which is, I think we're just going to use an H3. Okay, so now that we have this, actually let's first just append these to the container. Oh, can't see. Button. And then we also do the same for our result. So what we did now is just basically append two elements to our container. This is not doing a lot. So what we're going to do right now is we're going to get an observable from the click event on our button. And for that we're going to call observable from event. And we're going to choose the button, and we're going to choose the click event. And now we have this observable, which we can then use to maintain state, basically. And we're just going to use the aforementioned scan method. Actually, let's first map every click, because the click emits a mouse event, like the JavaScript DOM mouse event. We're just going to map every click to the value 1, because we want to, every time we click, we want to update the value by 1. So then we're going to call scan, and scan takes a seed and an accumulator. So it's basically like, you've probably seen this with a fold, basically. And that's exactly what it does. So now what this is our state. And it's an observable of type int. There, exactly. And what we can do now is subscribe to this observable, which means that we're just going to ask it to give us data every time it updates. And I'm just going to call state.subscribe, and then I'm just going to say we're just going to want to change the text content of our result to be n.toString, since n is our integer, our accumulated value. And now this should be our first program. Let's need to start up SPT. Sorry. Dun, dun, dun. Okay, and now we can run. Actually, let's just run fast.js, which is basically like compile but emit a JavaScript file, and the tilde, the squirrely whatever thing that if you work with SPT, you probably know that it's just gonna wait for file changes and do that. So let's check out what we just did in the browser. Okay, so we've got this button, and every time we click it, we get some kind of update, right? So this is very, very basic. I think immediately what we can see is this has some kind of problems because we're still doing a lot of imperative stuff here, right? This whole thing is completely imperative, and also every time we call the subscribe method, we get a subscription, and what that does is basically it holds the resources that the observable needs, right? So under the hood, this from event call right here, it calls, it adds an event listener to that element, right? And if we don't get rid of that, once the element is removed from the DOM, we will leak memory, right? So that's why we need to, at the end, at some point, we need to call subscription.close. Actually, not, it's unsubscribe, sorry. Unsubscribe at some point. But obviously, if we just call it right here, our program wouldn't work. But so these are a couple of problems that we have. Another problem we can see is this works very easily because like this is very simple. But what if we had like some sort of lists and all? It would very quickly become very, very difficult to do, right? So if this was, instead of like just one integer, it would be a list of person or something. Then inside the subscribe, we'd have to create some sort of representation of that list. And the difficult part is, if we update that list, we don't know what the old value was. So we would have to discard the old list and recreate it every time, which would be terribly, terribly inefficient. So what is the answer to that solution? The solution to that is Iwash. Iwash is a small library or framework, whatever you prefer, that I created to mitigate exactly those problems that we just faced. And the first problem was, of course, we somehow need to abstract away from the DOM. And to do that very efficiently, we can use a virtual DOM library. Who here has heard of virtual DOM? Okay, that's quite a few. Yeah, but basically what virtual DOM is, it's an in-memory representation of the DOM tree, and it's pretty cool because it's completely immutable. But the only thing you do is you create if you want to update something, you create a new virtual tree with those changes, and then you can compare it to the old tree of virtual DOM elements, and the engine, the virtual DOM library, will see the differences and will only change these in the real DOM, which makes it terribly, terribly efficient. So React uses it, Cycle.js uses it, Vue.js, all these modern frameworks. Basically, Virtual DOM is like the new, I don't know, like Beatles. Everyone uses it. The second thing, of course, is the subscriptions, right? We talked about this. Outwatch knows exactly when a DOM will be removed, when a node will be removed from the DOM, so it can just unsubscribe exactly when you don't need this anymore. And the third thing is we're removing or restricting the need for higher order observables. Higher order observables are basically observables of observables, and in some libraries they're heavily used because they can offer another layer of extraction. But if you think about our principle of reactive programming, that we just have streams of data, then it doesn't really fit. Like streams of streams, it doesn't really make any sense in our conceptual view. And some libraries, like the signal libraries in PureScript and Elm, they completely forgo their idea, and they don't even allow you to create any higher order signals, basically, because it's a library restriction. So I can't completely forbid it because I can't control what the user codes in the end. But I definitely want to nudge the users in a way where they don't have to deal with that at all if they don't want to. Okay, so let's look at some more code. Basically, let's just re-implement this with Outwatch. See, this is fairly simple. We can just get rid of all of this imperative code, and we still want an observable from clicks. So we'll just create a small handler that that will create exactly this. Then instead of subscribing and unsubscribing, we'll just create a virtual DOM tree. We'll just call this tree for now, and it will be a div. And inside we'll have a button, and that button, on any click, we want to pipe those click events to our clicks observable, and we also want it to say click me. So basically, what we're doing here is we're using functions to describe this virtual tree, right? These div functions, they're just a function that takes some sort of inputs, like other virtual elements or attributes. Like, for example, we could set here the ID to, I don't know what, ASD, some ID, or the class or whatever. So it's basically just a DOM representation mapped to functions, right? So if anyone has used React with JSX, it's basically what JSX does under the hood. It's basically like JSX without the XML. And then we wanted here an H3, and we wanted the events of the state to go in here. So now let me save this and look at the code. Oh, we didn't run it. So now, actually, this is this is a good example, because now what this is, it's just a V node, like it's a V tree, like we said. So this doesn't actually do anything. We have to tell the framework to actually render this, and we'll just pass a query selector, and then we'll pass the root tree, and now it should actually do something. Let's see. Yeah, we get the same app as before, but actually we can see here this is completely declarative and very easy to look at, I think. And yes, immediate question, sure.
Yeah, could you show innovative JavaScript code?
So the JavaScript code, I can show that in the end, sure. Yeah, okay. So another question, sure.
Okay, so how is your implementation? Okay.
Okay, yeah.
Okay, so you probably know Scala tags, like
Yeah.
another library for
Yeah.
Scala.js.
It's based a lot on that. It's very similar.
It looks very similar. So what's the actual difference? Does Scala tags create a DOM immediately, and yours is like virtual, or is there some other difference?
There's actually a couple of differences. Scala tags creates also something like a virtual DOM tree, but it's not mapped to any virtual DOM library. It's just a representation of the DOM, and then you can create. Actually, ScalaText allows you to create a string out of it, or you can just say .render and it will render it to an element, and you get a DOM element, but it doesn't actually map to any virtual DOM library. And like you said, it's very, very similar. It has like a few minor differences. The first, of course, is it doesn't allow callbacks. Like I couldn't say click and then add some kind of callback here, because that would be imperative, and I didn't want people to do that. And of course, it has some extra method like this child method, which just basically, under the hood, it subscribes to an observable and sets the state to the children of this element.
Okay, so basically your library is enabling the user to work with observables.
Exactly, that's what it is.
Okay,
yes.
so that's the main difference, I think.
Yeah, you could say that.
Okay.
Yeah, sure.
Okay, thanks.
Yeah, sure. Okay, so next thing I want to do is create a simple to-do list, because apparently that's the cool thing to do these days. So we'll start with that. It's actually fairly simple. What we want to do is we'll want to create an observable of a list. So to do that, first we need another handler. We'll call these submissions. These will be observables of the individual submissions. So we'll just create a string handler, because they're going to be strings. And what we can do with these submissions is actually fairly simple. We can, again, just use the scan function, and we'll just pass an empty list as the seed. We need to use we need to give the type here, so Scala is happy. And then we can just say, we just want to append the list to the, like every time we get a submission, we just want to append the list. So this whole thing will now return an observable of list string, right? So this is going to be our state. What we can do next is basically now we have a list of strings, but we probably would like to wrap each of those strings in an LE, a list item. So we're just going to make a view for that. So we're just going to say state.map, and then we're going to map the list inside to a list item. So we're just going to say map, and we have a to-do in here, and we're just going to say LE to-do. So this now should give us, like view should be an observable of list of vnodes. Okay, so far so good. So now let's create the representation. We're just going to create an input element. We're going to have a placeholder that says to do, and we're going to say on every input we just want to pipe those events into the submissions. Okay, and then at the end we want to, instead of an H3, we just want an unordered list where the children, like we just saw the child element, we can do the same with children if we have an observable of list of vnode instead of an observable of vnode. So we're just going to say children view there. And now this should work. Except, no. Didn't save it. Okay. Let's just save. Okay. Here we go. So now, oh shit. Okay, so every keystroke will actually create a new element in a list. So this is not what we wanted. Okay, so let's go back to the drawing board. We can see here that input string will just emit an event every time we input something into the thing. So instead of doing this, we're just going to create a state for the text fields. So we're just going to call this text field state, and it's going to be another string handler. And what we can do with Iwash is we can just combine these observables. So instead of here, let's just move this to this, and instead of, let's just indent this right. So it looks good. So instead of just, now we have this text field state and submissions doesn't get any events. So what we're going to do is we're going to add a button that on every click will emit the state of our text field. Actually, we gotta put it in parentheses and push it to our submissions. Put a comma. And now this should work. Oh, let's just add a text to this button. Submit. Huh, okay. So do laundry, for example. Yay. Okay, so this is a very, very basic implementation of a to-do list. But you can see here it's just a couple of lines of code, and I think it's pretty concise and declarative. So you could play with this for a while. We could add like a delete. We could add, like right now, if we do something here and submit it, the text field doesn't get cleared. Well, maybe I can just put it a little bit to left. Is that better? Yeah. Okay. So there are still a few things to do, but instead of just iterating on this, I'm just gonna show you a different example, and that is this is something I get asked all the time. That's form validation. It's either that or HTTP, and HTTP is a little bit more complicated. You need to set up a server and all that, so we're just gonna do a form validation. Okay. So, first thing we're gonna do is we're going to think about what kind of app we want to build for our form validation example, and we're going to want to just have like a basic sign up with the user, and he's going to have a name and an email, so very, very basic. But we also want to display a list of errors when it's invalid, like we want to get immediate feedback. So let's create an ADT for exactly that. We're just going to call it validation error. And then our errors are actually, our requirements are that the name has at least 6 characters. I don't know why. Ask the project manager. And we're going to add the length. And it's gonna be it's gonna extend validation error. And the second, oh, hello. Lost the. Did I do something? Oh, okay. Hello? Oh well.
Maybe the battery is down.
Maybe the battery's dead. Yeah, sure. I can do this. Yeah, I'm an improviser. Okay, so next thing is we're gonna check for invalid emails. So just gonna have the email to our validation. The other thing we're going to do next is we're going to create a display method. So these, we could call the toString method on the validation error, but we actually want to give out a helpful error message. So it's going to take an error of type validation error, and it's going to return a string. And it's just, we're just going to match on the error and say case the name is too short. Actually, it's just define a minimum name. A minimum length, name length, which is 6, and then we're gonna say, we're just gonna say, hey, your name was length long, but needs to be min length long. Okay. And the other case is the invalid email, and we're just going to say, dude, please enter a real email. $email isn't valid. Something like that. Okay. So the other thing we need to do is we need to write validation functions for each of these. We could use the either type, or what I prefer obviously is the validation type from cats. It's basically like, who knows the validation type of cats? Okay, that's quite a few, but it's basically like an either, but it can accumulate errors. So okay, let's just write a validation function for our name. I'm just going to call it validate name. And it will return a validated NEL. What that means is it's a validated, it's like basically an either of a non-empty list on the left of error and of string on the right, because we want the validated name at the end. So we're just going to add this and a string. And to do this, we're just going to check if the name length is larger or equals to the min name length. And then if it is, we're just going to return the name length. Actually, no, we're just going to return the name as valid. And if it's not, we're just going to create a new invalid email. Invalid email, but name too short, error, and we're going to add the length here, and we're going to say this is an invalid non-empty list. Okay, and then we're just going to do the same thing for the email. It's going to be a validated NEL of validation. It's going to have the same type, basically. And we're going to check. I'm not going to do full email validation. So please.
Can you scroll up?
Sure.
We're done.
This, right? Yeah. Okay, sure. Oh, okay. Yeah. Okay, we're back. Alright, we're just going to check if the string contains an @ symbol. Yeah, it's not exactly email validation, but, you know, it's a demo. And then we're going to create an invalid email if it's not valid. There. So, next thing we're going to do is we're going to create a view if the user is valid. And we're just going to call it valid view. It's going to take a user, type user, and it's going to return a vnode. And it's just going to be like an h3 of a string where we say, I don't know, user.name, and just, yeah, it's not going to be anything big. So this is a view when everything's valid, and then we want to create an error view, basically. And that's going to take our errors, which are a non-empty list of validation error. And it's also going to return vnode. So what we're going to do is we're just going to create another header, actually a quite big one. It's going to say the following errors occurred. And then, actually, let's just wrap all of this in a div. And then we're going to add an unordered list with the errors mapped to a list item. So we have an error. I'm just going to map it to a list item of display. Did I call it display error? Yeah, display. So we're going to just display this error. And actually we have to, since UL expects var args, we have to do this, which expands a sec. Or actually we need to convert, because non-empty list is not a sec, we need to call to list. Okay. So yeah, now we get that. Now let's write a function that takes a name and an email, and returns either a list of errors or the valid user. So we're going to have a name type string and email of type string, and we're gonna return. Actually, let's just check out what we'll return. So yeah, let's just add it. Whatever. Validated NEL of validation error. Validation error or user. Validation, not validated error. There we go. Okay. And basically, what we're going to do is we're going to use applicative notation. So don't be afraid. This isn't some weird magic. It's just basically it's very similar to a for expression, but it uses applicatives instead. And then we can map this to a user, and then basically we got exactly what we want. So yeah, now we basically have written the logic. Now let's write the representation. So we're gonna have an input field. Of course, we're gonna have two input fields. The first one will have a placeholder name, and then I'm just going to copy and paste that. This one's going to have email. And now we're going to create we're going to create two handlers, because we need one for each. So we're going to create a names handler, which is just a string handler, because they're both just going to emit strings. I'm just going to add it right here, input string to names. And we're going to do the same for the emails, which we need to create. So now we've got to somehow combine these and then actually map it to some kind of vnode to display it. So Rx has the combine latest function. Let's just check that out. Combine latest. And the cool thing, actually this is not what I wanted. So this is going to create a stream when this image loads. You could, I think I might not have any internet here. Okay, whatever. Basically, this is going to create a stream where whenever one of the elements emits, the combined stream will emit some kind of combination of the two, and it's always going to take the latest from the other that didn't emit. So we're just going to use the validate user function, and then this should return about observable of validated NEL validation error user. So this is going to be our users. And then the last thing we have to do is create a view out of this. And for that, we're just going to map over the users. And since we have a validated here, we're just going to fold that validated in case. And what this does, it basically deconstructs this. So it takes a non-empty list of validation error to something else, and a user to the other, to that same type B. And our type B is going to be vnode because we want a representation. So we're just going to create the pass the error view and the valid view. So far so good. And now I think the only thing that's left is to just bind this to the DOM. Okay. Let's see if it worked. No. Did I not? Does this not compile maybe? Or maybe it's just taking... Ah, okay. So now we have a name and an email. Let's just add some kind of name. And then, oh, okay, we see, dude, please enter real email, blah, blah, is invalid. But also, if this is too short, we have error accumulation. Okay, so let's just enter something real. And, I don't know, real name, blah, blah. And there we see it changes according to the error status. So basically that's form validation in Iwash. Let's just go back to the slides one last time and check out some conclusions. Reactive programming is functional programming plus time. What this means is what we've seen exactly. Functional programming is how to sequence data functionally. That's basically what we're all doing with Scala all the time. Reactive programming adds the time element. And we can use Iwash to model lots of different architectures. For example, we can model the Elm architecture if someone has used Redux before, or the Elm architecture. They're very, very similar. We can implement a Redux store in 4 lines of Iwash. The other thing we've seen is that applications can be modeled by using only pure functions, and we also saw that the functional programming patterns still apply. Like cats validated the data type, it still works. Everything we can use in functional programming, all of these abstractions we created over the time, they all still apply to reactive programming in Iwash. And the cool thing with this RX library is that we can work at an extra level of abstraction, but we still are able to maintain flexibility. That is something that was very important to me when creating Iwash. I sought out to not create some very highly opinionated framework, but just create something that's flexible. So there's no notion of components like in React. There's just functions. If you want to create a component, you can create a case class, or you can just use a function. You can just do whatever you want. You can model your app by using only local state with the scan function, or you can use a store. You can, we used a Redux store. There's one provided by Iwash, but none of it is required. You can just do whatever you want. And yeah, that basically concludes my talk. Thank you all for listening, and if there's any questions, I'd love to hear them.
Hello, thank you for your talk. I have 2 questions.
Sure.
First one is, are you using this library in production, maybe the place that you are working? And the other question is, what the major differences between other Scala.js RX libraries like Bind in Scala or the U- framework?
Okay. Yeah, sure. The first question, if I understood you correctly, if I'm using this at work.
Yes.
And no, sadly not. I'd love to, obviously, but it's still fairly young. I think it's the first release was in November last year, so it's still maturing. I know a lot of people. I've got a lot of contributors coming to me and saying, "Oh, we'd love to use this in production," and they give me bug fixes and stuff. And it's growing, but I don't think I know that some people use it for their for like internal applications. But I don't think it's not like heavily adopted yet. It has like 90 stars in GitHub, so if that's any indication. And to your second question, I actually haven't used U-, but binding Scala is pretty different. It also uses this reactive approach, but it basically hides it away from you. So something like you don't get access to the observables, as far as I know, and that means you can't really abstract with the time. You can't use the debounce pattern, or you can't buffer in a given time period. You can't really abstract over it. And also, I think it doesn't use a virtual DOM approach. I think the author, he says he doesn't need it. I'm not sure how the performance is. I know the performance for Iwash is pretty good, more or less, but yeah, that's all I can give. I haven't done like these huge comparisons yet.
Thank you.
Yeah, thank you. Any more questions? Okay. Oh.
I'm missed the start of your conversation. It's about Scala.js, yes?
Yes, exactly.
Is code is stable enough to... I'm not interested in the UI part. I'm mostly interested in Ajax and algorithmic part of conversion.
The what part? The
algorithmic.
algorithmic part, yeah.
Loops and parallel things or whatever. Is it workers that are managing multi-threading on client side?
Actually, you mean like web workers?
Yeah.
Yeah, actually that's, since you don't have shared state with web workers, you can't really do parallelization yet. I'm not sure how that's going to be in the future, but Scala.js, the compiler, is very, very stable. I know a lot of people use it in production, including SAP, I think, and Twitter. So that's very stable. Yeah, that's basically.
Okay. And what can you compare it to, for example, in this regard, to TypeScript, for example?
TypeScript.
Yeah. What will be the profit for maintenance of huge, complex algorithmic code with Scala.js versus TypeScript, for example?
Well, I think what Scala.js allows you is basically you can use all the cool libraries like cats and shapeless and all of these things. You can use Scala check for property-based testing, which means I think if you want to have some really complex business logic, writing it in Scala.js is probably going to be a lot more. First of all, type safe. You get all the benefits of Scala. And if you compare Scala as a language to TypeScript, I think it's basically a pretty unfair comparison to TypeScript.
Actually, in their website in Scala.js, they have the comparison of
Yes.
JavaScript 5, 6, and TypeScript versus Scala, and like you can just see the samples of the code. Scala is much cleaner always and much smaller if you just want to have the same result for the algorithm.
Thanks.
So better
Yeah.
check there.
Sure.
And can you show the JavaScript code?
Oh yeah, sure. It's not gonna be nice, so you're not gonna like it.
JavaScript, nobody likes it. Some
Make
people
us
don't
feel
like
to
Scala,
look at
so
the
it's a
settings.
mix.
Or bytecode.
Actually, I'm not sure. It's somewhere. Oh, that's not the project. It's in target here. Should be in there. So this is the fast up version. You can get an even more optimized version of the whole thing, which is going to minify and all that thing. I think it runs a Google Closure compiler. I don't know where it's loading right now, but yeah, this is basically the Scala environment, and then it's a lot of code, a lot of small things, because it has to basically add the whole runtime. So a lot of this can still further be optimized away, but the fast.js is optimized for speed and not for size. So yeah, this is a lot of. I have no clue what this is. So yeah. See, it has to add these big integer things, and because they're needed for the Scala standard library. Sure.
So if could I use Scala.js, for example, for using these play2 views?
Play2 views. Yeah, Scala.js integrates very nicely with Play. You can use SBT Web to compile Scala.js into JS, and you can't use twirl, obviously, but why would you want to if you have Scala.js? But yeah, you can do that, sure.
And
Okay.
what are other limitations for compiler? For example, if I import like any jar to my code, obviously it probably won't compile, right?
If it's Java, no. If it's Scala, yeah.
If it's Scala, even if it's the jar, it will like transform it to the JS
right?
Yeah, basically, it will transform all the Scala code to JS. Yeah. Sure.
So doesn't the library also have to do something special in the SPT build to make it, publishable to Scala.js? The jar doesn't contain the source code, right? It just contains the class files.
Well, I guess yeah. It depends on the jar. If you have a jar of source code, then it works. But it can't compile Scala. It can't compile JVM bytecode to JS. It only compiles Scala source code. So yeah, I'm sorry. Yeah, it depends on the jar. Yeah. Okay. I'm just gonna.
Like this?
In case subtract.
Okay.
Stage -1, and we can create the store, producer. And what we can then do, instead of, we could create like 2 buttons. Oh, he's going to talk soon, so just like if we click on one of these, we're just going to send it to this.
We're going to have more functional programming, and I think the best recommendation I can give for me personally was the Red Book by the Functional Programming in Scala. When I first read that, my mind was completely blown. It was so cool. I didn't know you could do all these awesome things. Another cool thing that really helped me understand is, of course, CATS, the library. But also, I mean, just play around with stuff. Like, there's so much cool stuff out there that I can't really say like which things to recommend without actually doing a disservice to so many other things. So just, I don't know, just play around with all the stuff. That's what I'd probably say, yeah.